lecture 7, we are going to talk about mixed product. Mixed product. Okay. By definition, a mixed product is the dot product between a vector v dot the cross vector a cross b. You see, this is a scalar quantity, okay? Because I have a v and I have a vector, I'll call this vector here as vector c. So v dot c is equal c dot v. See? Now, this is a scalar quantity because it is a dot product of two vectors. Be careful, later, ahead, you're going to see that the dot product is not necessarily a scalar. Okay? Could be a tensor. You see this later. But here, I'm emphasizing that's a dot product between two vectors. Necessarily is a scalar. And also this is invariant. What means? What do you mean by invariant? This result does not depend on the coordinate system. Okay? Any coordinate system. Now, let's erase here. So, another point, you don't need to put parentheses here. You don't need. Why? Because you never first you're gonna use the dot product first, because dot product is a scalar, and there is no sense a cross product between a scalar and a vector. Okay? Don't use this parenthesis. Likewise, the same here. Now, I'll call this here vector ci. This case. Let's call vector c, sorry. So, v dot v c is equal vi ci. Okay. Is equal ci vi. This is a scalar quantity, invariant. But ci is equal epsilon I jk aj bk. You see? Because c is a cross product between a and b. So this, you see, this from the previous lecture, lecture 6. Now let's substitute over here. So v dot c is equal vi epsilon I jk ci aj bk. Now attention now. V dot c, two vectors. The right hand side cannot have free index. Only dummy. You see, I is dummy, J is dummy, and K is dummy. So I can develop this as a sum. V1 epsilon 1 jk plus V2 epsilon 2, sorry, I missed here, aj bk plus V2 epsilon 2 jk aj bk plus V3 epsilon 3 jk aj bk. Now let's focus on this term over here. V1 epsilon 1 jk aj bk. Now j and k could be 1, 2, 3 because you are using the Cartesian coordinates. So I have two options, only two. Why? J cannot be 1 because from the definition of permutation or Levi-Civita, if you have a repeated, this will be 0. So it's okay, it will be 0, you put 0 there. But you will not affect the result. So the two hypotheses for I is equal 1 is J is equal to, let's maintain K here. Another possibility is J is equal 3. This is K. Now, carefully you can see that when I is equal 1, J is equal 2, K must, there is no option, must be 3. Okay? So this is equal to 3. So 1, 2, 3. See? And also this K, this will be 3, 2. You see? Because I is equal 1, 1, 2, 3. 1, 3, 2. Recall that epsilon 1, 2, 3 is equal 1. And then epsilon 1, 3, 2 is equal minus 1. You see, this is an odd permutation. See? Clear. You can see clearly here. You just put 1, 2, 3, and then you repeat 1, 3, 2. Just here. There is one cross here, and here there is no cross. So one intersection means an odd permutation. Okay? That's why here it's minus 1. So this term over here, okay, V1 epsilon 1 jk, I can split as follows. I have, let's put it here, aj bk. So this, there are two possibilities, okay? Or possibility, this or this, okay? I will sum. So this will be epsilon 1, 2, 3, A2, B3, plus epsilon 1, 3, 2, A3, B2. This is plus 1, this is minus 1. I'm sorry, the whole thing here is multiplied by V1. You see, V1 that multiplies this. So this is equal V1. This already got, this is plus, okay, A2, B3 minus A3, B2. You see? This here. This is minus. You see, this is minus over here. Now, easily the other terms. You see? I just rotate, permutate this over here. You see, look how easy. Okay. After, let's put here 1, 2, 3, 1, 2, so on. You see, after 1, I write B2. So this epsilon 2 JK, AJ, BK. It's clear. Let's look at here. Is equal V2. Now, parentheses. After 2 comes 3. So this A3, B after 3 is 1 minus, look at here, A3 is 1, B3. Quite easy. Just to permutation over there. And the third term is V3, is epsilon 3 JK AJ BK is equal, after 2 is 3, after 3 is 1, after 1 is 2, minus 2 and B1. You see? Now, that's the answer. Okay? That's the answer. There's a sum of this term plus this